Our solar system, a cosmic ballet of planets orbiting the Sun, has always been a source of fascination and mystery. What if there were a hidden world lurking in the distant reaches of our solar system? This is the enigma of Nibiru, or Planet X, a hypothetical celestial body captivating imaginations. Planet X is inferred from gravitational anomalies observed beyond Neptune. The search for Nibiru, or Planet X, is a tale of scientific inquiry and the vastness of space. Despite decades of searching, no conclusive proof has been found. The mystery of Nibiru, or Planet X, remains unsolved, challenging our understanding of the solar system.
The origins of the Nibiru myth trace back to ancient Sumerian civilization. The Sumerians believed in Nibiru, a celestial body with an elongated orbit. Nibiru's passage was said to cause cataclysmic events. These tales have inspired awe and fear through generations. Some researchers see Nibiru as evidence of an ancient celestial encounter.
In astronomy, the search for Nibiru, or Planet X, is driven by observation, hypothesis, and testing. Astronomers study celestial motions, looking for anomalies in the solar system. Unusual orbits of trans-Neptunian objects suggest a massive, unseen object. These TNOs have elliptical orbits, possibly influenced by a distant planet. This planet could be several times the mass of Earth, far beyond Pluto. Mathematical models test this hypothesis, suggesting a distant Planet X.
The vastness of space presents a formidable challenge in the search for Nibiru, or Planet X. Even a planet several times the mass of Earth would be extremely faint and difficult to detect at such great distances. Astronomers have employed a variety of techniques in their quest for this elusive world, including ground-based telescopes, space-based observatories, and sophisticated data analysis methods. One of the most promising tools in the search for distant objects is the Panoramic Survey Telescope and Rapid Response System, or PAN-STARRS, located atop the Haleakala volcano in Hawaii. PAN-STARRS, equipped with the world's largest digital camera, scans the sky nightly, searching for moving objects including asteroids, comets, and potentially undiscovered planets. Another powerful instrument is the Wide Field Infrared Survey Explorer, or WISE, a space telescope launched by NASA in 2009 to map the entire sky in infrared light. Infrared radiation, unlike visible light, can penetrate dust and gas, making it ideal for detecting cool, faint objects that might be missed by traditional telescopes. Despite these advanced technologies, the search for Nibiru, or Planet X, has so far been unsuccessful. No object matching the hypothetical characteristics of this planet has been definitively identified. However, the absence of evidence is not evidence of absence.
Section 5. The power of gravity's pull. Gravity governs celestial motions and aids in the search for Planet X. Unseen objects are inferred by their gravitational influence. Neptune's discovery was guided by its effects on Uranus, similar to Planet X. TNO clustering suggests a massive, distant object. This planet's gravity could be shepherding icy bodies, like a dog herding sheep. The Kuiper Cliff, a drop-off beyond 50 AU, hints at Planet X's influence.
Section 6. When science meets speculation. The search for Nibiru, or Planet X, highlights the interplay between science and speculation. While scientists rely on rigorous observations and testable hypotheses, speculation often fills the gaps in our knowledge, offering tantalizing possibilities that may or may not be supported by evidence. The concept of a hidden planet has captured the public imagination, inspiring countless conspiracy theories and doomsday predictions. Some believe that Nibiru is on a collision course with Earth, its arrival imminent and catastrophic. Others claim that governments and scientific organizations are aware of Nibiru's existence but are concealing the truth from the public. These conspiracy theories, often fueled by misinformation and a distrust of authority, can spread rapidly through the internet and social media, creating unnecessary fear and anxiety. It is important to approach such claims with a healthy dose of skepticism, relying on credible sources of information and evidence-based reasoning. The scientific community, while acknowledging the possibility of undiscovered objects in the outer solar system, remains cautious about attributing observed anomalies to a single massive planet. The evidence for Planet X, they argue, is circumstantial and open to alternative explanations.
Section 7. A universe of possibilities. The search for Nibiru or Planet X is a testament to the human spirit of exploration and our insatiable curiosity about the universe we inhabit. It is a reminder that our understanding of the cosmos is constantly evolving as we make new discoveries and refine our theories. While the existence of Planet X remains an open question, the search itself has yielded valuable scientific insights. The study of TNOs, for example, has revealed a complex and dynamic region of the solar system that was once thought to be empty and uninteresting. The development of new technologies and observational techniques, driven in part by the search for distant objects, has enhanced our ability to study the universe in unprecedented detail. These advancements have led to the discovery of thousands of asteroids, comets, and other celestial bodies, expanding our knowledge of the solar system and beyond. The universe is vast and full of mysteries, many of which may never be fully understood. The search for Nibiru or Planet X, whether it ultimately proves successful or not, reminds us of the importance of scientific inquiry, the power of imagination, and the humbling realization that there is still so much more to learn about the cosmos we call home.
Section 8. The Quest for Knowledge. The ongoing debate surrounding Nibiru or Planet X underscores the importance of critical thinking, scientific literacy, and the responsible dissemination of information. In an age of instant access to vast amounts of data, it is crucial to distinguish between credible sources and misinformation. The scientific method, with its emphasis on empirical evidence, peer review, and testable hypotheses, provides a framework for evaluating claims and separating fact from fiction. By approaching extraordinary claims with a healthy dose of skepticism and demanding extraordinary evidence, we can avoid falling prey to pseudoscience and conspiracy theories. The search for Nibiru or Planet X, regardless of its outcome, serves as a reminder of the power of curiosity, the importance of questioning assumptions, and the boundless potential of human ingenuity. It is a testament to our enduring fascination with the cosmos and our desire to unravel the mysteries of the universe. As we continue to explore the solar system and beyond, we are likely to encounter more anomalies and puzzles that challenge our current understanding. The key is to approach these challenges with an open mind, a commitment to scientific rigor, and a sense of wonder and awe at the vastness and complexity of the cosmos.
Section 1. Echoes of Nibiru. The name Nibiru echoes through millennia, whispered on the winds of time from ancient Mesopotamia. This region, nestled between the Tigris and Euphrates rivers, was home to advanced cultures. They left behind knowledge on clay tablets in cuneiform script. Among these texts are references to a celestial body known as Nibiru. The interpretation of these texts is complex and contentious, yet the allure of uncovering ancient secrets drives researchers to delve into Mesopotamian cosmology. The Sumerian civilization left behind a legacy of remarkable intellectual achievements. Their cuneiform tablets offer glimpses into their understanding of the cosmos. Stories of gods, epic battles, and creation myths are interwoven with astronomical observations. The Sumerians meticulously tracked the movements of stars and planets. They believed celestial movements held profound significance for human affairs. Their astronomical knowledge was advanced, predating the telescope by millennia. The Sumerian texts describe Nibiru as a celestial body associated with the god Marduk.
Section 3. Zecharia Sitchin and the 12th Planet. The modern fascination with Nibiru owes much to the work of Zecharia Sitchin, a Russian-born author and proponent of the ancient astronaut theory. Sitchin, in his book The 12th Planet and subsequent works, argued that Nibiru was not a myth but a real planet inhabited by a race of advanced beings called the Anunnaki. According to Sitchin's interpretation of Sumerian texts, the Anunnaki visited Earth in ancient times, creating humanity through genetic engineering and leaving behind a legacy of knowledge that influenced the development of civilization. Sitchin's theories, while captivating to many, have been widely rejected by mainstream science and scholarship. His interpretations of Sumerian texts have been criticized as inaccurate and selective, often twisting the original meaning to fit his preconceived notions. Sitchin's lack of formal training in Sumerian language and history, coupled with his reliance on questionable sources and interpretations, has further eroded his credibility among academics. Despite the lack of scholarly support, Sitchin's works have had a significant impact on popular culture, fueling countless books, websites, and documentaries dedicated to Nibiru and the Anunnaki. The idea of ancient astronauts visiting Earth and influencing human evolution has captured the imaginations of many, tapping into a deep-seated fascination with the unknown and the possibility of extraterrestrial life.
Section 4. Deciphering the tablets. The interpretation of ancient texts is a challenging and often subjective endeavor. Languages evolve over time, words and phrases take on new meanings, and cultural contexts shift, making it difficult to fully grasp the intended meaning of texts written centuries or millennia ago. The Sumerian language in particular presents unique challenges for scholars. As a language isolate, Sumerian has no known genetic relationship to any other language, making it difficult to decipher its grammar and vocabulary. Despite these challenges, scholars have made significant progress in understanding Sumerian language and culture through decades of painstaking research and the discovery of new texts. The use of comparative linguistics, the study of related languages, and the analysis of contextual clues within the texts themselves has allowed researchers to piece together a more complete picture of Sumerian cosmology and their beliefs about Nibiru. The cuneiform tablets that mention Nibiru often describe it in astronomical terms, referring to its movements in relation to other celestial bodies. These descriptions, while tantalizing, are often fragmentary and open to multiple interpretations. The Sumerians did not have a modern understanding of the solar system, and their descriptions of celestial phenomena were often intertwined with mythology and religious beliefs.
Section 5. A Celestial Enigma. The debate over the nature of Nibiru hinges on the interpretation of these ancient texts and the weight given to different pieces of evidence. Those who favor a literal interpretation of the Sumerian accounts argue that the texts provide a remarkably accurate description of a celestial body with an unusual orbit. They point to the Sumerians' apparent knowledge of planets beyond Saturn, planets that were not discovered until centuries later as evidence of their advanced astronomical knowledge. However, critics of the literal interpretation argue that the Sumerian descriptions of Nibiru are too vague and inconsistent to be taken as evidence of a real planet. They point out that the texts often use figurative language and symbolic imagery, making it difficult to separate fact from fiction. The Sumerians, like many ancient cultures, viewed the cosmos through a mythological lens, attributing human-like qualities and motivations to celestial bodies. Moreover, the literal interpretation of Nibiru as a planet with a long elliptical orbit that periodically enters the inner solar system faces significant scientific challenges. Such an orbit would be inherently unstable, subject to gravitational perturbations from other planets that would eventually eject it from the solar system or cause it to collide with another celestial body.
Section 6. The Babylonian Perspective. As the Sumerian civilization declined, their cultural influence was absorbed by the Babylonians, who rose to prominence in Mesopotamia in the 2nd millennium BCE. The Babylonians inherited and adapted many aspects of Sumerian culture, including their writing system, literature, and cosmology. The Babylonian creation myth, known as the Enuma Elish, draws heavily on Sumerian mythology, incorporating and reinterpreting earlier Sumerian stories. In the Enuma Elish, the god Marduk, the patron deity of Babylon, plays a central role in the creation of the world. Marduk, armed with powerful weapons and imbued with divine authority, defeats the primordial goddess Tiamat, who represents chaos and disorder. From Tiamat's slain body, Marduk fashions the heavens and the earth, establishing order and creating humanity. The Enuma Elish, like many creation myths, reflects the cultural values and worldview of the society that created it. For the Babylonians, Marduk's victory over Tiamat symbolized the triumph of order over chaos, civilization over barbarity. Marduk's association with the planet Jupiter, the largest planet in our solar system, further reinforced his status as a powerful and benevolent deity. Section 7. Marduk, a cosmic counterpart. The association of Marduk with both a planet and a celestial body associated with creation and destruction has led some researchers to speculate about a possible connection between Marduk and Nibiru. Could the Sumerian Nibiru and the Babylonian Marduk be two different names for the same celestial object, viewed through the lens of different cultures and mythologies? This intriguing possibility, while speculative, highlights the challenges of interpreting ancient texts and the potential for cross-cultural influences to shape our understanding of the past. The Babylonians, in adapting Sumerian mythology, may have reinterpreted the concept of Nibiru, incorporating it into their own pantheon and associating it with their patron deity, Marduk. However, it is essential to approach such connections with caution, avoiding the temptation to force ancient texts into preconceived notions. The Babylonians, while inheriting much from the Sumerians, also developed their own distinct culture and beliefs. Marduk, while sharing some similarities with earlier Sumerian deities, emerged as a unique and powerful figure in Babylonian mythology, representing the aspirations and anxieties of a rising empire. Section 8. Interpreting Ancient Cosmology. The interpretation of ancient cosmology requires a nuanced understanding of the cultural and historical context in which it arose. Ancient civilizations did not have the benefit of modern scientific knowledge and often relied on mythology, symbolism, and religious beliefs to explain the world around them. The Sumerians and Babylonians, despite their advanced astronomical observations, viewed the cosmos as a realm imbued with divine power and purpose. Celestial bodies were not merely balls of rock and gas, but were seen as gods, goddesses, and other supernatural entities that influenced human affairs. The stories of Nibiru and Marduk, whether interpreted literally or symbolically, offer a glimpse into the rich tapestry of ancient Mesopotamian cosmology. They remind us that our understanding of the universe is constantly evolving, shaped by new discoveries, cultural perspectives, and the enduring human quest to make sense of our place in the cosmos.
The mystery of Nibiru lies at the intersection of myth, science, and the enduring human fascination with the unknown. The ancient texts that speak of this enigmatic celestial body offer a tantalizing glimpse into the beliefs and knowledge of civilizations long gone. Yet the interpretation of these texts remains a subject of debate, with scholars divided over whether Nibiru represents a real celestial object, a mythological entity, or a complex blend of both. The search for Nibiru, whether driven by scientific curiosity or fueled by speculation, has captured the imaginations of many, inspiring countless books, websites, and documentaries dedicated to uncovering its secrets. The idea of a hidden planet lurking in the distant reaches of our solar system, its arrival heralding either doom or enlightenment, taps into our deepest fears and aspirations, reflecting our enduring fascination with the unknown and our place in the cosmos.
Our solar system is a celestial ballet, a delicate dance of planets, moons, asteroids, and comets. The sun, our star, reigns supreme, its immense gravity holding this cosmic dance in check. Each celestial body follows a predictable path, its orbit determined by its mass and distance from the sun. Yet amidst this cosmic harmony there are whispers of discord, subtle anomalies hinting at an unseen dancer.
The outer solar system, a realm of icy giants and enigmatic dwarf planets, is a region of intense scientific interest. Subtle gravitational tugs, perturbations in the orbits of distant objects, suggest an unseen object influencing its neighbours. Could these whispers be the signs of Planet X, a hidden world lurking in the darkness? Evidence comes from trans-Neptunian objects in the Kuiper Belt, their elliptical orbits hinting at a massive unseen object. This hypothetical Planet X could be hundreds of astronomical units from the Sun, escaping our detection. The curious case of Sedna and Eris. Sedna and Eris are two dwarf planets with highly unusual orbits. Sedna, discovered in 2003, has an extremely elongated orbit. Its orbit is so strange that astronomers struggle to explain it. Eris, discovered in 2005, is slightly larger than Pluto with an eccentric orbit. Its discovery played a key role in Pluto's demotion to dwarf planet. The unusual orbits of Sedna and Eris have led to speculation about a scattering event by a passing star or rogue planet. Section 4. A ninth planet. In 2016, astronomers Konstantin Batygin and Michael Brown of the California Institute of Technology, Caltech, made headlines around the world with their announcement that they had found evidence for a ninth planet in our solar system. Their evidence, based on detailed mathematical modeling and computer simulations, suggested the presence of a planet approximately 10 times the mass of Earth, lurking far beyond the orbit of Pluto. Batygin and Brown's work focused on the orbits of 6 extreme TNOs, objects with highly elliptical orbits that take them hundreds of AU from the Sun. These 6 objects they found all have a similar orbital alignment, their paths through space suggesting that they are being influenced by the gravitational pull of a massive unseen object. The probability of this orbital alignment occurring by chance, Batygin and Brown calculated, was extremely low, less than 0.007%. This, they argued, strongly suggested the presence of a ninth planet, Planet X, lurking in the outer solar system, its gravity shepherding these distant objects into their peculiar orbits. Batygin and Brown's work has generated intense excitement and skepticism within the astronomical community. Their findings, while intriguing, are based on indirect evidence, the gravitational influence of Planet X inferred from the orbits of other objects rather than observed directly. Section 5. Modeling the unseen. The search for Planet X highlights the power and limitations of mathematical modeling in astronomy. Astronomers use mathematical models to represent physical systems and processes, allowing them to make predictions and test hypotheses about the universe. In the case of Planet X, astronomers have developed sophisticated models of the outer solar system. These models have been used to simulate the orbits of TNOs, allowing astronomers to compare the simulated orbits to the observed orbits. Their models predict that Planet X, if it exists, should have a highly elliptical orbit.
Section 6. The limits of observation. The search for Planet X is hampered by the vastness of space and the limits of our technology. Even a planet several times the mass of Earth would be extremely faint and difficult to detect at the distances involved. The outer solar system is a dark and cold place, far from the sun's warmth, and even the most powerful telescopes struggle to see objects that are so small and so far away. Astronomers have employed a variety of techniques in their quest for Planet X, including ground-based telescopes, space-based observatories, and sophisticated data analysis methods. They have scanned the skies for signs of Planet X's faint glow, looking for its telltale signature in the light from distant stars. They have searched for subtle wobbles in the positions of stars, telltale signs of the gravitational tug of an unseen planet. Despite these efforts, Planet X has so far eluded detection. The absence of direct observational evidence has led some astronomers to question its existence, arguing that the gravitational anomalies observed in the outer solar system could be explained by other factors, such as the cumulative gravitational influence of many smaller objects, or the presence of a distant, undiscovered disk of debris. Section 7. Alternative explanations. While the search for Planet X continues, it is important to remember that the gravitational anomalies observed in the outer solar system could have other explanations. The universe is a complex and often surprising place, and astronomers are constantly refining their understanding of how it works. One alternative explanation for the clustered orbits of some TNOs is the cumulative gravitational influence of many smaller objects in the outer solar system. The Kuiper Belt, where most TNOs reside, is a vast and sparsely populated region, but it still contains trillions of icy bodies, ranging in size from small pebbles to dwarf planets like Pluto. The combined gravitational pull of these objects, even though they are individually small, could be enough to nudge some TNOs into their observed orbits. Another possibility is the presence of a distant, undiscovered disk of debris in the outer solar system. This disk, similar to the Kuiper Belt, but located much farther from the Sun, could be composed of icy bodies left over from the formation of the solar system. The gravitational influence of this disk, if it exists, could be subtly influencing the orbits of TNOs, creating the observed clustering. Astronomers are also investigating the possibility that the gravitational anomalies in the outer solar system could be caused by modifications to our understanding of gravity itself.
Section 8, a universe of unknowns. The search for Planet X is a testament to our insatiable curiosity about the universe. Our understanding of the cosmos is constantly evolving with new discoveries. The outer solar system is a dynamic region teeming with icy objects and secrets. Discoveries like Eris challenge our definition of a planet and hint at unseen worlds. The universe is vast and full of mysteries, many of which may never be fully understood.
The quest for new planets has long been a driving force in the field of astronomy. The history of these searches reveals a fascinating interplay between theoretical predictions and observational discoveries, each building on the other to expand our understanding of the solar system. Perhaps the most famous example of this dynamic is the discovery of Neptune in 1846, which was predicted mathematically before it was observed in the night sky. The story of Neptune's discovery begins with the observation of irregularities in the orbit of Uranus. Astronomers noticed that Uranus did not follow the expected path predicted by Newtonian mechanics. These discrepancies led some to hypothesize the existence of an unseen planet exerting a gravitational influence on Uranus. French mathematician Urbain Le Verrier and British mathematician John Couch Adams independently performed calculations to predict the position of this hypothetical planet. Their predictions guided German astronomer Johann Galle, who ultimately discovered Neptune near the predicted location. This remarkable achievement validated the power of mathematical modeling in astronomy and set a precedent for future searches for unknown celestial bodies. The discovery of Neptune left an indelible mark on the field of astronomy, demonstrating the power of mathematical predictions and reinforcing the belief that there could be other unknown planets waiting to be discovered. It also highlighted the importance of collaboration and the sharing of information among astronomers, a practice that has become even more crucial in the modern era of space exploration. Following Neptune's discovery, astronomers turned their attention to the possibility of other planets beyond its orbit. The concept of a Planet X emerged as a potential explanation for remaining irregularities in the orbits of the outer planets. This idea captivated the imaginations of astronomers and prompted extensive searches throughout the 19th and 20th centuries. In the early 20th century, American astronomer Percival Lowell became one of the most prominent figures in the search for Planet X. Lowell, who founded the Lowell Observatory in Flagstaff, Arizona, was convinced that a ninth planet existed beyond Neptune. He embarked on a systematic search, meticulously photographing the night sky and analyzing the images for signs of a distant planet. Although Lowell did not live to see the fruits of his labor, his efforts laid the groundwork for future discoveries. His meticulous records and detailed calculations provided a valuable resource for subsequent astronomers who continued the search for Planet X. The search for Planet X took a significant turn in 1930 with the discovery of Pluto by Clyde Tombaugh at Lowell Observatory. Using blink comparison, Tombaugh identified a faint object moving against the stars. This object, named Pluto, was hailed as Planet X, marking a monumental achievement. Pluto's discovery cemented Tombaugh's place in astronomical history. Astronomical surveys have played a crucial role in the search for Planet X, providing comprehensive data sets for scanning vast sky regions. These surveys, using both ground-based and space-based telescopes, have revolutionized our ability to detect distant celestial bodies. The Palomar Sky Survey in the 1950s was one of the earliest and most influential, using the 48-inch Schmidt telescope. It led to the discovery of numerous asteroids, comets, and other celestial bodies. Technological advancements have since enabled even more detailed surveys. The Sloan Digital Sky Survey, launched in 2000, has mapped over a quarter of the sky, capturing data on millions of celestial objects.
Modern technology has revolutionized astronomy, providing powerful tools to explore the cosmos with unprecedented precision. Advances in telescope design and imaging technology have expanded our ability to search for distant objects. Large aperture telescopes collect more light and provide higher resolution images. Examples include the Keck Observatory, the Very Large Telescope, and the upcoming Extremely Large Telescope. Instruments like adaptive optics and spectrographs enhance image clarity and analyze celestial light. Space-based telescopes like Hubble have advanced our understanding of the outer solar system. The James Webb Space Telescope will further revolutionize our view of the cosmos. Two significant astronomical surveys are Pan-STARRS and WISE. These missions have provided valuable data and insights into the outer solar system. Pan-STARRS, atop Haleakala in Hawaii, has the world's largest digital camera. It scans the sky nightly, searching for asteroids, comets, and undiscovered planets. Its goals include tracking near-Earth objects and discovering new celestial bodies. Since 2010, Pan-STARRS has discovered many asteroids, comets, and TNOs. Launched in 2009, WISE mapped the sky in infrared light. Infrared radiation can detect cool, faint objects missed by traditional telescopes. WISE was reactivated as NEAR-WISE to focus on near-Earth object detection. It detected hundreds of millions of objects, including asteroids, comets, and distant galaxies. Together, Pan-STARRS and WISE have advanced our understanding of the outer solar system.
Section 7. The limitations of current surveys. Despite the remarkable achievements of modern astronomical surveys, there are still significant limitations and challenges that hinder the search for Planet X. The vastness of space, the faintness of distant objects, and the limitations of current technology all contribute to the difficulty of detecting a hypothetical planet in the outer solar system. The outer solar system extends far beyond Neptune, encompassing the Kuiper Belt and the distant Oort cloud. Objects in these regions are often small, faint, and difficult to detect, even with the most powerful telescopes. Another limitation is the sensitivity and resolution of current instruments. Faint objects, especially those far from the Sun, can be challenging to observe. The vast amounts of data generated by surveys pose a significant challenge for analysis. Machine learning has improved efficiency, but there's still a risk of missing subtle signals. The search for Planet X is complicated by the need to rule out alternative explanations for observed anomalies. Distinguishing between these possibilities requires careful analysis and additional evidence. Despite these challenges, the search for Planet X continues to push the boundaries of our knowledge and capabilities.
Section 8. The future of planetary discovery. The future of planetary discovery holds exciting possibilities, driven by advancements in technology and the dedication of the astronomical community. Key developments like the extremely large telescope in Chile will enhance our ability to search for distant objects. The ELT's 39-meter primary mirror will make it the largest optical and infrared telescope in the world. Its light-gathering power will enable astronomers to observe faint, distant objects with greater clarity. The Vera C. Rubin Observatory will conduct the Legacy Survey of Space and Time. This 10-year survey will provide a dynamic view of the cosmos, aiding in the discovery of transient objects. Space-based observatories like the James Webb Space Telescope will continue to play a crucial role. Future missions like Le Voir and Habex could further enhance our ability to detect and study distant objects. The future of planetary discovery is bright, promising to expand our understanding of the outer solar system.
Section 9. Reflecting on the search for Planet X. The search for Planet X, also known as Planet 9, represents one of the most compelling and enduring quests in the field of astronomy. It is a journey that has spanned centuries, driven by the curiosity and determination of astronomers seeking to unlock the secrets of our solar system. As we reflect on this ongoing search, it is important to recognize the broader implications and lessons it offers. First and foremost, the search for Planet X underscores the importance of perseverance and the iterative nature of scientific inquiry.
In the vast expanse of our solar system, gravity orchestrates a silent symphony, a delicate dance of celestial objects bound together by their mutual attraction. The Sun, our star, anchors this cosmic ballet, its immense gravitational pull holding the planets, moons, asteroids, and comets in their respective orbits. Like dancers responding to the rhythm of an unseen conductor, these celestial bodies move in predictable patterns, their movements governed by the laws of physics.
Gravity, the weakest of the fundamental forces yet the most far-reaching, exerts its influence across space. It binds galaxies, shapes star orbits, and holds planets around suns. Invisible yet ever-present, it shapes the cosmos. The sun's gravity holds planets in elliptical orbits. Planets influence their moons, creating tides. Even asteroids and dust are subject to gravity. Astronomers detect unseen objects by their gravitational effects. Like ripples in water, gravitational perturbations reveal massive objects. The orbits of celestial bodies are not perfectly stable over time. They wobble slightly due to gravitational perturbations. These wobbles can accumulate, leading to significant changes over millions of years. In the outer solar system, these wobbles are more pronounced. Some TNOs have highly elliptical orbits, suggesting influence by a massive unseen object. This has led to the hypothesis of Planet X acting as a cosmic shepherd. The Kuiper Belt, a vast ring of icy bodies beyond Neptune, is a region of intense scientific interest. It is home to a diverse population, from small icy bodies to dwarf planets like Pluto and Eris. Astronomers have observed a sharp outer edge where the number of objects drops off dramatically. One explanation is a massive object, like Planet X, beyond its boundaries. Its gravitational influence could be clearing out a path, scattering or ejecting smaller objects. The Sun's gravitational pull is not the only force acting on objects in our solar system. While the Sun's gravity is dominant, the planets also exert their own gravitational influence on one another, creating a complex web of gravitational interactions. These interactions, while subtle, can have significant effects on the orbits of celestial bodies over long periods. Astronomers have observed that the Sun's axis of rotation is tilted at a slight angle relative to the average plane of the planet's orbits. This tilt, while small, is difficult to explain by the current models of solar system formation. Some astronomers have speculated that this tilt could be the result of a gravitational tug from a massive object in the outer solar system, such as Planet X. Imagine a spinning top. If you were to gently nudge the top, its axis of rotation would tilt slightly. Similarly, the gravitational influence of Planet X, if it exists, could be subtly tugging on the Sun, causing its axis of rotation to tilt over time. This tugging effect could explain the observed tilt of the Sun's axis, as well as other subtle gravitational anomalies observed in the outer solar system, such as the peculiar clustering of some TNO orbits.
The search for Planet X is daunting, hampered by vast distances and faintness. Even a planet several times Earth's mass is hard to detect directly. The outer solar system is dark and cold, far from this warmth. Faint light from distant objects easily lost against the background glow. Orbits in the outer solar system are vast and slow. Planet X could take thousands of years to orbit the Sun. Its movement would be excruciatingly slow, hard to distinguish from stars. Astronomers are like detectives, piecing together faint evidence. They rely on gravitational perturbations to infer Planet X's presence. The search for Planet X showcases astronomers' ingenuity and perseverance.
Section 7. Refining our gravitational models. The search for Planet X is not simply a matter of pointing telescopes at the sky. It involves developing sophisticated mathematical models, incorporating the gravitational influence of all known objects. These models allow astronomers to simulate movements over time, taking into account gravitational pulls. By comparing predictions to actual positions, astronomers can identify anomalies indicating unseen objects. The development of these models is an iterative process, requiring constant refinement.
Section 8. The importance of continuous observation. The search for Planet X is an ongoing endeavor, requiring patience, persistence, and continuous observation. The outer solar system is a vast and ever-changing place, and new discoveries are being made all the time. Astronomers are constantly monitoring the skies, using both ground-based and space-based telescopes to collect data on the positions and movements of celestial objects in the outer solar system. These observations, combined with the ever-evolving mathematical models of the solar system, are gradually painting a more detailed picture of this distant realm. The more data astronomers collect, the more refined their models become, and the more likely they are to detect the subtle gravitational fingerprints of Planet X if it exists. Each new observation, each new data point, brings astronomers one step closer to unraveling the mystery of this hypothetical world. The search for Planet X highlights the importance of long-term astronomical surveys and the value of continuous observation. It is a reminder that some of the most profound discoveries in astronomy are not the result of single, isolated observations, but rather the culmination of years, even decades, of meticulous data collection and analysis.
Section 9. A universe of hidden connections. The search for Planet X, whether it ultimately proves successful or not, speaks to the interconnectedness of our solar system and the far-reaching influence of gravity. It reminds us that even the most distant objects in our solar system can have a subtle but profound impact on the movements of their neighbors. The gravitational anomalies observed in the outer solar system may ultimately be explained by the presence of Planet X, or they may point to other as yet unknown phenomena. Regardless of the outcome, the search itself has already led to a deeper understanding of the outer solar system and the complex gravitational interactions that shape the orbits of celestial bodies in this distant realm. The search for Planet X is a testament to the insatiable curiosity of astronomers and their unwavering determination to explore the unknown. It is a journey that has already yielded valuable insights into the workings of our solar system, and it holds the promise of even more profound discoveries in the years to come.
The human mind is inherently curious, driven by an innate desire to explore the unknown and unravel the mysteries of the universe. This thirst for knowledge has propelled countless expeditions to the farthest reaches of our planet and inspired generations of scientists to peer deep into the cosmos, seeking answers to fundamental questions about our place in the grand scheme of things. The search for Planet X, a hypothetical world lurking in the outer reaches of our solar system, embodies the spirit of exploration and the allure of the unknown. It is a quest driven by tantalizing clues, fueled by the possibility of discovering a new world, and tempered by the humbling realization that our understanding of the universe is still far from complete. The very idea of an undiscovered planet, a hidden world orbiting our sun alongside the familiar planets of our childhood textbooks, captures the imagination. It speaks to our sense of wonder and our desire to believe that there is still so much more to discover, that the universe holds secrets waiting to be unlocked. The search for Planet X is a reminder that science is not a static body of knowledge, but a dynamic process of discovery. It is a journey into the unknown, guided by observation, driven by curiosity, and fueled by the possibility of finding something truly extraordinary.
The search for Planet X has profoundly impacted astronomy. It has driven new technologies and advances in observational techniques. The possibility of a massive planet beyond Neptune has led to new theories. The search has also led to the discovery of numerous outer solar system objects. It has been a boon to astronomy, advancing knowledge and technology. The outer solar system, a realm of perpetual twilight, presents formidable challenges for astronomers. Vast distances and faint objects make this study daunting. Imagine spotting a firefly in a vast darkened stadium. Now, Imagine it moving slowly, flickering in and out of view. Astronomers use cutting-edge technology and ingenious techniques. Sensitive detectors capture the faintest glimmers of light. Sophisticated software enhances the visibility of faint objects.
The quest for evidence. The scientific method demands evidence. Extraordinary claims require extraordinary evidence. Astronomers are in a meticulous quest for evidence of Planet X. They use powerful telescopes to scan the skies, searching for a point of light moving against stars. Indirect evidence may also play a crucial role. Gravitational anomalies suggest an unseen massive object. The search for Planet X highlights the tension that often exists in science between the excitement of new possibilities and the need for rigorous skepticism. On the one hand, the possibility of discovering a new planet in our solar system, a world that has eluded detection for centuries, is an exhilarating prospect. It is a reminder that our understanding of the universe is constantly evolving, that there are still wonders to be uncovered, and that the cosmos holds surprises yet to be revealed. On the other hand, scientists are trained to be skeptical, to question assumptions, and to demand evidence. Extraordinary claims, such as the existence of a new planet, require extraordinary evidence to be taken seriously. The history of science is littered with examples of intriguing theories that ultimately failed to stand up to scrutiny, hypotheses that were ultimately discarded when contradictory evidence emerged. In the case of Planet X, the evidence thus far is intriguing but circumstantial. The gravitational anomalies observed in the outer solar system, while suggestive of a hidden planet, could potentially be explained by other phenomena, such as the cumulative gravitational influence of a large number of smaller objects, or even modifications to our understanding of gravity itself. This tension between possibility and doubt is a healthy and necessary part of the scientific process. Section 6. The importance of scientific skepticism. Scientific skepticism, often misunderstood as negativity or close-mindedness, is in fact a cornerstone of the scientific method. It is the practice of questioning claims, demanding evidence, and subjecting hypotheses to rigorous scrutiny. It is not about being cynical or dismissive, but rather about approaching claims with a critical eye, demanding that extraordinary claims be supported by extraordinary evidence. In the context of the search for Planet X, scientific skepticism is essential. The evidence thus far, while compelling, is not definitive. The gravitational anomalies observed in the outer solar system could be explained by other phenomena, and it is important to rule out these alternative explanations before concluding that a new planet is the most likely culprit. Scientific skepticism helps to guard against confirmation bias, the tendency to seek out and interpret evidence in a way that confirms our pre-existing beliefs. It encourages scientists to consider all possible explanations, to be open to the possibility that they might be wrong, and to be willing to change their minds when presented with compelling evidence. In science, the simplest explanation is often the best. Known as Occam's razor, it favors explanations with the fewest assumptions. For gravitational anomalies, Planet X is one explanation, but not the only one. Smaller objects' combined gravitational pull could explain these anomalies, or our understanding of gravity might be incomplete. The search for Planet X has prompted astronomers to re-evaluate their assumptions about the outer solar system. The possibility of a large, undiscovered planet challenges our current models of solar system formation. Planets form from a rotating disk of gas and dust around a young star. Particles collide and stick together, growing into planets. This model struggles to account for a large planet like Planet X at such a distance. The discovery of Planet X would require astronomers to refine their models, potentially leading to a paradigm shift. The mystery of Planet X persists, a tantalizing enigma that continues to intrigue astronomers and capture the public imagination. The evidence, while suggestive, remains inconclusive, leaving astronomers in a state of suspenseful anticipation. The search for Planet X is a testament to the enduring power of scientific curiosity, the relentless pursuit of knowledge, and the humbling realization that there is still so much we don't know about the universe we inhabit. It is a reminder that science is not a static body of knowledge, but a dynamic process of discovery, a journey into the unknown that is often as rewarding as the destination itself. Whether Planet X ultimately proves to be real or a figment of our collective imagination, the search itself has already yielded valuable insights. It has driven the development of new technologies, spurred advances in observational techniques, and led to a deeper understanding of the outer solar system. The mystery of Planet X, therefore, is more than just a search for a single object. It is a journey of exploration, a quest for knowledge, and a testament to the enduring power of human curiosity.
The mystery of Nibiru, or Planet X, remains an unresolved enigma, a cosmic puzzle that has captivated and confounded astronomers, conspiracy theorists, and the public alike for decades. The evidence, a tapestry woven from ancient texts, astronomical anomalies, and tantalizing gravitational whispers, is both intriguing and inconclusive, leaving us with more questions than answers. Despite years of dedicated searches using increasingly sophisticated telescopes and observational techniques, no definitive proof of Nibiru's existence has been found. The elusive planet, if it exists, remains hidden in the depths of space, its presence hinted at but never confirmed. The lack of direct observational evidence has led some to dismiss the idea of Nibiru as nothing more than a fringe theory, a product of overactive imaginations and a misunderstanding of scientific principles. Others, however, maintain that the evidence, while circumstantial, is too compelling to ignore, suggesting that our solar system may yet harbor secrets that have eluded us for centuries. The debate over Nibiru's existence highlights the challenges inherent in exploring the vast and often unyielding realm of space. It is a reminder that our understanding of the universe is constantly evolving, shaped by new discoveries, technological advancements, and the relentless pursuit of knowledge.
The search for Nibiru underscores the profound sense of wonder and uncertainty in our exploration of the cosmos. The universe is vast and mysterious, filled with phenomena that challenge our understanding. From subatomic particles to galaxy superclusters, we are only beginning to comprehend the universe. Each discovery reveals our ignorance and the nature of the universe. The quest to understand our place in the cosmos is a perpetual exploration of the unknown.
The idea of hidden worlds, of planets lurking unseen in the depths of space, has captivated the human imagination for centuries. From the ancient Greek philosophers who speculated about the existence of a counter-Earth, to the modern-day astronomers searching for exoplanets orbiting distant stars, the allure of the unknown has been a driving force in our exploration of the cosmos. The search for Nibiru taps into this primal fascination, offering the tantalizing possibility of a world hidden within our own solar system. A world that has escaped detection for so long, perhaps harboring secrets that could revolutionize our understanding of planetary formation, the history of our solar system, or even the origins of life itself. The enduring appeal of hidden worlds lies not only in the thrill of discovery, but also in the potential they hold for expanding our cosmic perspective. Each new world we find, whether it be a distant exoplanet or a hypothetical planet lurking in the outer reaches of our solar system, challenges our preconceived notions about the diversity and complexity of the universe. These discoveries remind us that our own planet, our own solar system, is but one small part of a much grander cosmic tapestry, a tapestry woven from countless stars, planets, and galaxies, each with its own unique story to tell. Section 4. The significance of the search. The quest for Nibiru has spurred advances in astronomy and fueled the public's imagination. It has driven the development of new telescopes and techniques, pushing the boundaries of our ability to detect faint objects. These advancements have enabled the discovery of countless objects in the outer solar system. The search has also forced astronomers to reevaluate their models of the solar system's formation. Section 5. Science's relentless pursuit. The search for Nibiru, whether it ultimately proves successful or not, exemplifies the relentless pursuit of knowledge that lies at the heart of the scientific endeavor. Scientists are driven by an insatiable curiosity, a desire to understand how the universe works, and a willingness to follow the evidence wherever it may lead, even if it means challenging established theories or venturing into uncharted territory. The scientific method, with its emphasis on observation, hypothesis testing, and peer review, provides a rigorous framework for this pursuit of knowledge. It is a process of continuous refinement, where theories are proposed, tested, and either supported or refuted based on the available evidence. The search for Nibiru, like many scientific quests, has been marked by both moments of excitement and periods of frustration. Tantalizing clues have emerged, only to be later explained by other phenomena. Hypotheses have been proposed, tested, and sometimes discarded when contradictory evidence emerged. This process of trial and error, of constantly questioning assumptions and refining our understanding, is an essential part of the scientific method. The search for Nibiru reminds us that the universe is full of mysteries, that our knowledge, however vast it may seem, is but a tiny island in a vast ocean of the unknown. It is a reminder that we should approach the cosmos with a sense of humility, acknowledging the limits of our current understanding and embracing the possibility that there is still so much more to discover. The history of science is replete with examples of discoveries that overturned long-held beliefs, revealing a universe far stranger and more wondrous than we could have imagined. From the realization that the Earth is not the center of the universe, to the discovery of quantum mechanics, which shattered our classical notions of reality, science has consistently shown us that the universe is full of surprises. The search for Nibiru, regardless of its outcome, should inspire us to approach the unknown with open minds and a sense of adventure. It should encourage us to question our assumptions, to challenge established theories, and to embrace the possibility that the universe may hold secrets far beyond our current comprehension. The enduring fascination with Nibiru, a hypothetical planet with no definitive proof of existence, speaks to the power of human curiosity, our innate desire to explore the unknown, and our insatiable thirst for knowledge. It is this curiosity that has driven humanity to explore the farthest reaches of our planet, to venture into space and to probe the deepest mysteries of the cosmos. Curiosity is the engine that drives scientific discovery, the spark that ignites the flame of inquiry. It is the force that compels us to ask questions, to seek answers, and to never stop exploring, even in the face of seemingly insurmountable challenges. The search for Nibiru, like all scientific quests, is ultimately a testament to the power of human curiosity.
The search for Nibiru, while focused on a single, hypothetical object in our solar system, offers a valuable opportunity to step back and consider our place in the grand cosmic scheme. The universe is vast beyond comprehension, filled with billions of galaxies, each containing billions of stars, many of which likely harbor their own planetary systems. Against this backdrop of cosmic immensity, our own planet, our own solar system, shrinks to an almost insignificant point. Yet it is within this tiny corner of the universe that we have evolved, developed the capacity for thought and wonder, and embarked on the quest to understand the cosmos and our place within it. The search for Nibiru, whether it ultimately proves successful or not, reminds us of the vastness of the universe and the relative insignificance of our own existence. It is a humbling realization, but it is also an empowering one, for it is in the face of this cosmic immensity that our own achievements, our own quest for knowledge, take on an even greater significance.
The search for Nibiru, like the broader quest to understand the universe, is a never-ending journey. Each new discovery, each answered question, inevitably leads to new mysteries, new puzzles to solve, and new frontiers to explore. The universe is a vast and ever-changing place, and our understanding of it is constantly evolving. The search for Nibiru reminds us that science is not a destination but a journey, a continuous process of exploration and discovery. It is a journey that requires patience, persistence, and a willingness to embrace uncertainty. As we continue to explore the outer reaches of our solar system and beyond, we are likely to encounter more anomalies, more mysteries that challenge our current understanding. The key is to approach these challenges with the same spirit of curiosity and determination that has driven the search for Nibiru, embracing the unknown with open minds and a relentless pursuit of knowledge. For it is in the pursuit of the unknown, in the quest to unravel the mysteries of the universe, that we truly discover the boundless potential of the human spirit.